Welcome everyone, my name is Stefano and I'm a product manager at AWS. The webinar today is about Amazon API Gateway. We are going to start by talking about why we built API Gateway. What was your feedback that drove us to build this product? And then we'll give an overview of how API Gateway works and dive deeper into each one of the features we mentioned. We'll save some time at the end of the webinar for some questions and answers, but feel free to ask questions throughout the webinar and John will answer your questions. Let's start with talking about why we built API Gateway. The obvious answer is that at AWS we run a lot of APIs and we have been running APIs at scale for the past 10 years. And over time we've learned quite a few lessons on how to manage these APIs. So we decided to package everything we had learned so far and give it to you as a product. We also heard from you and we talked to a lot of our customers to gather their feedback. And this is what you told us about managing APIs. The first thing is that versioning an API is not necessarily difficult, but it's often an afterthought. You publish an API and then 1 month later, you decide to make a breaking change and you realize that you were not ready to publish different versions of these APIs. API Gateway helps you create this layer in front of your existing backend and helps you consider versioning from the get-go. Next is monitoring access by third-party developers. This is what we call undifferentiated heavy lifting. It's something you have to do. You have to build every time you publish an API, but it's not something that necessarily adds value to your business. So API Gateway can help you do this out of the box without requiring any work on your part. Similarly, access authorization is a very complex subject. It's something you have to build every time you publish an API, but it doesn't add value to your business. At AWS, we have a very comprehensive security and authorization infrastructure with our identity and access management product. API Gateway helps you leverage what we have built at AWS and identity and access management to authorize access to your APIs. Traffic spikes and generally managing the scale of a backend often creates operational burden and expenses. With API Gateway, we help you manage this by throttling requests and generally preventing attacks to your backend. Finally, we heard from developers who are new to AWS and are new to backend development, and they asked us to help them build a backend that didn't require any servers and didn't require any operational infrastructure or intervention from their part. So we launched Amazon API Gateway. The first thing, as we discussed, is creates a layer in front of your existing API and helps you manage the versioning and the different environments, which we call stages, for your API. For example, development, beta, production, etc. We help you create and distribute API keys, and we manage monitoring of these API keys so that you know at any time how many calls each API key has made. For security, we help you leverage AWS authorization and authorize calls to your API exactly the same way AWS services do, using signature versus 4. Alternatively, you can leverage your own existing authorization mechanism simply by forwarding your headers or authorization keys to your backend. To manage network traffic, we give you the ability to throttle requests to protect your backend. And we also offer additional protections at the edge. Finally, for customers who don't want to manage any infrastructures or server, we already had the tool for you, AWS Lambda, that allows you to run code on demand without managing any servers. API Gateway creates a front to AWS Lambda and allows you to run your Lambda function in response to requests. And while we were building it, we added a few more features along the way. The first is the ability to create a dedicated managed cache You can tell API Gateway which parameters form the unique key of an item in your cache and the time to live for each one of these items, and we will manage this cache on your behalf. We integrate with CloudFront to create a global distribution for your APIs and make it available in all of our 54 points of presence around the globe. This is entirely managed by API Gateway. You don't need to know about CloudFront, you don't need to worry about CloudFront, and you don't need to pay for CloudFront. The additional benefit of this is that it gives you DDoS protection, both layer 7, or let's call them malicious requests, as well as layer 3 SYN floods, for example. API Gateway can also generate client SDKs based on your API definition. At the moment, we can generate client SDKs for iOS, Android, and JavaScript, and we'll go deeper into all of these features later on in the presentation. Next, to help you automate your workflow, we added Swagger support. A lot of our customers told us that they work with Swagger. They like to have their Swagger API definitions in their source repository so that they can modify them and track them in the local environment. We offer an open source Swagger import tool that you can simply build as part of your build and deployment process. And it can pick up your Swagger definition, import it into API Gateway, and deploy it during the build. Further, we've extended Swagger and added some custom tags that you can use to specify API Gateway specific fields, such as the Lambda function we need to call, or whether you want to use IAM for authorization. API Gateway also allows you to transform data as it's flowing into the system from a request and as it's coming out from your backend as a response. We use Apache Velocity to do this, and we'll have some examples later on in the presentation. So now let's take an overview of how Amazon API Gateway works. And this slide shows you the standard flow of a request being originated from a client, a mobile app, a website, or another service. The request flows over the internet to the closest CloudFront POP. At the POP, the request is intercepted and sent to API Gateway over the internal Amazon network. This reduces latency for your end users. Once the request reaches API Gateway, we check in the dedicated cache, if you have provisioned one, whether we have a response for this request. If we do, then we'll simply send back the response. Otherwise, we will call your backend. Your backend could be an AWS Lambda function or an endpoint hosted on EC2 or anywhere else that is publicly accessible on the internet. All requests as they flow through are monitored using Amazon CloudWatch in your account. You get the number of requests, you get the average latency, and you get the errors that are generated from the request. And this means you can set your own alarm and take action. This is a screenshot of an API setup in Amazon API Gateway. And we are showing it because we want to make some distinction and concepts clearer. On the left, you see you have your API structure. You have your resources and the methods within each resource. On the right, we have the configuration of a specific method. We've drawn this divider line in the middle, and you can think of this as the top part, how a request is handled. Method request is how API Gateway receives the request, which parameters it should look for, and how it should authorize the request. And then integration request defines how this request is passed to your backend. In this example, I'm connecting to a Lambda function, but this could be an HTTP endpoint you own. In the integration request, you can transform the data, for example, getting a path parameter or a query string parameter and constructing a body for a post request to your backend. At the bottom of the screen, we then look at how API Gateway handles the response, first from your backend as an integration response. There you can define how HTTP status codes or Lambda errors are mapped to a response to the client. And you can also transform the data as it flows through. The method response defines the shape of your API and which responses it will send to the client. You can have multiple response types, status codes, and content types. We can draw the same distinction looking at the screen this way, where on the left we have method request and method response. These define how your customers see your API, which parameters they should send in, and what the API will respond with. And on the right of this line, you define how the API interacts with your backend and how data is transformed on the way in or on the way out. Now, to give an overview of the concepts we'll be using throughout this presentation, API Gateway uses REST terminology. Our top-level item is an API. An API contains multiple resources, and each resource can contain a method and its settings. Resources are typed objects. What that means is that resources have a shape and a model that you can define. In the classic example of the pet store, you can have a pet resource, and that defines what a pet looks like and what its properties are. Each resource contains multiple methods, and methods are the coupling of a resource with an HTTP verb. So a method could be a get to the pet's resource. Once you've defined an API, you can take a snapshot of that configuration and deploy it to a stage. Stages is how we manage environments. As we said, for example, a development, a beta, or a production environment. And each stage can have its own configuration. For example, you may want to set a very low throttling limit and no caching for your development stage, and a much higher throttling limit and include a cache in your production stage. Stages are treated like tags, and you can give them any name you want, and you can have as many stages as you need. To manage versioning, we help you by cloning the configuration of one API into a completely new API so that you can keep working on both APIs at the same time and slowly deprecate the first version. We'll go into more details on this later. Because we take snapshots of your API configuration and we deploy them to stages, we can keep a history of your deployments. And at any time, you can tell us to roll back or roll forward to a previous deployment. To configure an API, you have a top-level element, which is your API. Within the API, you have your resources, for example, a resource called /paths. And within that resource, you have the methods, which are the /path plus an HTTP verb. Similarly, with deployments, you still have the API as the top-level item. And every time you declare a new stage, this becomes accessible through a base path. For example, /dev, /beta, and /prod. Now, if we look at how we manage versioning, this is a more practical example. We will start by declaring API 1, and we call this version 1. You will start configuring and building this API, and when you're ready, deploy it to a development stage. And you will keep configuring and deploying until you're ready to clone the configuration to a production stage. And your API will continue evolving. At some point, you will decide that you want to make a breaking change. You want to change the shape of your responses or the parameters a method receives. You cannot do this on the API version 1 because you have customers, you have developers interacting with this API. So what we help you do is clone the configuration of API v1 at that point in time and fork it into an API v2. You can keep working on both APIs at the same time. API v2 will have its own stages and go into production when it's ready. And you can slowly deprecate API 1, while you can also continue bug fixing it. Base paths are not the only way stages and API are accessible. You can also define custom domain names. A custom domain name for us is not just a top-level domain like yourapi.com. A custom domain name can include a subdomain as well as a base path. So from our previous example, you could declare a custom domain name called yourapi.com/v1 and point that custom domain name directly to the production stage of your first API. And you could then declare a second custom domain name called yourapi.com/v2 and point that to the production stage of the second API, which we cloned for the first one and called v2. Next, we're going to look at metering and authorization. This is done through API keys and, as we discussed, via IAM. API keys are built to meter usage of your APIs by other developers. API Gateway can generate API keys for you that have a random alphanumeric identifier associated to them. For each API key, you can define which API and which stage within an API they have access to. All requests made by an API key are logged in your CloudWatch. So at any time, you can go and check how many requests each API key has made. API keys are meant to meter access by other developers, and they're not considered a secure way to authorize access to your APIs. We recommend you use an additional authorization mechanism, a stronger authorization mechanism. And this could be your implementation of OAuth, or if you're starting from scratch, you can take advantage of AWS Identity and Access Management and Signature version 4. If you already have an OAuth provider or an OpenID provider set up, then you can simply tell Amazon API Gateway to forward your headers, your authorization headers, and we will pass them through, not authorize the API, and let your backend handle the verification of that token. Otherwise, if you decide to leverage AWS authorization, then you can ask API Gateway to verify the signature on your API request. And requests will need to be signed with a set of temporary AWS credentials. This is particularly important because API Gateway treats your service as a first-class citizen within AWS. Each one of your endpoints and methods is assigned a resource name, an ARN. And you can use these ARNs in your access policies for your roles or for your users within IAM. Now we have an example of a flow we've seen our customers build many times to leverage AWS SIG v4. They declare a login API, a post that receives a username and password. They have a Lambda function behind it that verifies this username and password against a user database, wherever that is. Once the credentials are verified, the Lambda function calls Amazon Cognito, a service that can generate temporary credentials that are tied to a role and are associated with a particular identity of the end user. The Lambda function calls Cognito a feature called Developer Authenticated Identities and simply tells Cognito that they have authenticated a user, they trust them, and this is their unique identifier. Cognito responds to that request with an OpenID token for the user and a unique identity ID. This OpenID token can then be traded for temporary AWS credentials. These credentials are formed by an access key, a secret key, and a session token, and they are returned back to the client. Temporary credentials with AWS last for 1 hour, and we often get asked, how do we manage the expiration of these credentials? We've built this system into the mobile SDK, and the generated SDKs take advantage of it. We have an interface called AWS Credentials Provider. This interface declares a single method called refresh. This method is called by the client SDK automatically whenever it doesn't have credentials or the credential it already has are expired. And you can see in my example, in the refresh method, I'm using my generated client to call a login, my login resource and method with a set of cached username and password I had. That login method returns the credentials object we discussed before with an access key, a secret key, and a session token. And all I do is set these in the temporary variables and return the task. This way, all you need to worry about is to implement this refresh method, and whenever the client SDK needs credentials to make an API request, it will simply call your refresh method before making the request. Another thing we've added is the ability to invoke other AWS services using the caller credentials. For example, if you are using AWS authentication and you are using Cognito credentials, the role that those credentials use define what the end user has access to. And you can tell API Gateway to verify the signature on those credentials and then invoke, in this case, the Lambda function using the same credentials that called API Gateway. And this way, the Lambda function will have the same permissions you have associated with your end user. Next, let's look at ways to protect your backend. And we group throttling and caching because both can serve to reduce latency and protect your backend from traffic spikes. Throttling allows you to set your burst request limit. When we receive a request and you are over that limit, we will automatically send back a throttling response. The burst limit is set in terms of requests per second, and you can set this on each stage, and within a stage override it for each method in your API. If you use our generated client SDKs, they already know how to handle the 429 HTTP response, which is the throttled response, and they will automatically perform what we call exponential backoff and keep retrying the call at higher and higher intervals. Caching is another way to first reduce latency for your end users because we check for responses in the cache before we trigger your backend. It can also help protect your backend from traffic spikes because if we have a response in the cache, then there's no need for us to call you. The cache is dedicated to you and it's provisioned for each stage. We have a number of options for cache machines, and you can go between 0.5 GB to 237 GB of cache. These are billed hourly as if they were instances. Well, this slide was supposed to have a bit more data, but it describes the flow of a request, and I'll talk you through it. When the request comes in, we first check whether the item exists in the cache. If it does exist in the cache, then there's no need for us to throttle the request because we can handle the traffic. So we'll simply return the response. If we can't find an item in the cache, then we will check your throttling setup and the status. If you're over your throttling limit, we will return a throttled response, the 429, and trust the client SDK to do the exponential backoff and retry that request. Otherwise, we'll execute it and call your backend. Finally, we want to cover input and output transformation. We mentioned this earlier. We use Apache Velocity to transform data on its way in from a request, as well as on its way out from a response. We've seen our customers do quite a bit with input and output transformation. The first thing is filter results. Very often, legacy backends and API return quite verbose output. And this is not something that you should return to a mobile client, for example, that's running on limited connectivity. So many of our customers use the transform templates to look at the response of their backend and, for example, loop over the array and discard the items they don't need, or clean the unnecessary tags before they return them to the client. Another example is to expose an RPC style API as a RESTful API. If we use a pet store example, in an RPC style API, to get the definition of a pet, we would have to make a post to a getPet path. In RESTful standard, instead, you would have your /pet resource, and you would make a get to it to get your pet. So what our customers do is use the data transformation to retrieve all the parameters that are sent from the get to the get, for example, the pet ID from the path, and build a body for the post request to their backend. And last is transforming JSON to XML. Some of our customers already had APIs running on their own backend, and these APIs used to return XML data. They wanted to move their backend and processing to AWS Lambda. However, Lambda only works with JSON and returns JSON. So they used API Gateway in between to capture the JSON from Lambda and transform it into XML before it's returned to the client. This allowed them to move their backend from their on-premise infrastructure or from EC2 machines to AWS Lambda without causing any disruption for their developers and end users interacting with their APIs. So we have a very basic example of a transform template here. The request is a get to a say hello method, and the Lambda function simply returns a message object that says hello world. On the way back, this needs to be transformed into a similar XML structure. And you can see the transform template at the bottom, where we use the input variable to read the JSON that's come from Lambda and save it into this root variable. And then we simply declare the structure of the XML as if it was a text file, and we use the root variable to access the message property of the response. This is a slightly more complex example, but it shows you the power of the transformation and its language. In this case, we were grabbing output from a DynamoDB request and transforming it so that it didn't have as many nested objects, and it was simply an array of items called service name, date created, and service ID. As you can see, we were again reading the input JSON in this input root variable. And then we have a for loop that loops over the items property of the response and creates this element variable. And from the element, we use JSON path to access the property we need. So each element had a service name property, and the service name property had the string or the S property. And at the end of the loop, you can see that we have an if statement to add the necessary commas. Throughout mapping templates, you can declare as many variables as you need, and you can perform quite complex transformations with access to some of the Java objects and properties behind it. You can have one mapping template per content type in your both request and response. In this example, I'm building a request for the Lambda function. And as you can see, what I'm doing is declaring an action property that simply specifies which class my Lambda function should execute from my Java source. And then I have a body property where I'm simply reading the entire JSON that was sent in the request. Our last topic is SDK generation. We introduced it briefly at the beginning, saying that API Gateway can generate client SDKs for iOS, Android, and JavaScript. Within your API definition, you can also declare the models of your requests and responses. Models are not mandatory, But if they are declared, then we can also generate the objects in the client SDK for the requests and responses rather than using generic JSON maps. Models are a top-level item within an API and can be shared across multiple methods. SDKs are generated based on your deployments. So for each stage, we can generate an SDK that runs on the current deployment active on that stage. As we said, you will have your models available as objects within the SDK. The benefits you get from using our generated client SDKs is that first, they already know how to handle throttled responses. So they will automatically do exponential backoff if they receive a 429. Secondly, that they know how to sign requests. So if you do plan to leverage AWS SigV4 to authorize access to your APIs, all you need to do is implement the credentials provider we discussed before and give the SDK the access key, secret key, and session token. The SDK will take care of the rest. We now support SDKs for Android, iOS, and JavaScript. So here I have an example of an SDK I generated for iOS. As you can see, it has generated all of my model objects for my getPet response and getPet requests. And when my responses are array or nest or contain nested items, then you can see it automatically also generated the nested items within the model. The generated client then automatically knows how to marshal and unmarshal requests and responses to match to your models. So in this case, I'm making a request to get my list of pets. This doesn't require any input. But you can see that I'm grabbing the output, the task.result, as my pets response, list pets response object. And the SDK automatically marshals this. And then I'm setting it into my table view. Thank you very much for your time. And now we can go into some of your questions. The first one is from Stuart, who asked whether there is an integration between API Gateway and other AWS services. The answer is yes. If you notice in my slide when I was showing the example of setting up a method, we had the Lambda option, we had the HTTP proxy option, but there was also an advanced button. With that advanced button, you can set up what we call an AWS Service Proxy. So you can simply tell us which other AWS service you want to connect with and what the request to that service should look like. And we will automatically either assume a role in your account or use the caller credentials to invoke that service. And we've seen this done before many times for customers creating CRUD APIs in front of a DynamoDB table, or for example, calling Elasticsearch directly. Another example of this is in customers creating a front end to Kinesis so they could collect data using the scalability and power of Kinesis, but making it look to the outside world as if it was their own API. So Greg asks whether API Gateway interfaces with services like Elastic Beanstalk for scaling and high availability. API Gateway does not talk directly to Elastic Beanstalk. However, because all your metrics are logged in CloudWatch, you can set up alarms and set up your auto-scaling groups to look at those metrics and set your own rules on how you want to scale. Next, Hardek asked whether they can migrate existing API keys generated through other software. The answer to that is no, not at the moment. However, we have heard this feedback before from many customers. So we have added this item to our roadmap and we will prioritize it according to the feedback we receive. So Shyam Sundar asked, can API Gateway interact with other API calls? And do we allow you to transform the output using velocity templates? Yes, that is correct. So you can configure API gateway to make an HTTP request rather than calling a Lambda function. And at the moment, HTTP is the only other protocol with support for making requests to a backend. And then you can receive this output, and yes, you can absolutely use the velocity template to transform the output from your backend before it's returned to the client. Next, we have Songwen, who asks how to configure API methods to forward the custom headers to my backend. There's two ways of doing this. First, you will need to declare the headers you expect in your method request, so where you define what the API request that API gateway should expect looks like. Once you've done this in your integration request, so where you define how API gateway talks to your backend, you will be able to either access these headers and put them in the body for Lambda, for example, or if you're connecting to another HTTP endpoint, you can declare headers that you send to that endpoint, which may have a different name from the one we receive, and simply tell API gateway that the value for that new header you declared comes from the method request header you defined. So yes, you can do this mapping both from header to header as well as header to body. Next, we have Vish, who asks, how does API gateway handle DDoS? So DDoS protection is something you get out of the box from API gateway. We use the CloudFront infrastructure for this. And if we look at layer 3, DDoS, SIM floods, for example, this is something we handle out of the box. You don't have to worry about it. We will recognize that a SIM flood is happening and block it. You don't even need to know about it. If there are malicious requests, then we use an algorithm to detect whether you are being attacked by a particular IP address or a range of IP addresses, and whether all those requests are failing with an error, and we will block it automatically. We have Mark, who asks what type of analytics are available on the APIs. By default, API gateway will collect metrics at the API level. And these metrics are the number of API calls, the latency of your API calls, and the 400 and 500 errors that are returned. Optionally, from each stage, you can tell API gateway that you want the same analytics, so the same 4 metrics for each method within your API. You can also enable logging, and we offer different logging levels. You can have error logs, you can have access logs, and you can also tell API gateway to dump in the logs the full request and response. And we will send all of this to the CloudWatch logs in your account. We have Scott, who asks what other options other than velocity is available for data transformation. At the moment, we only offer velocity as an option, but we have heard from other customers who are interested in using, for example, Mustache and JavaScript transformation engine. So we have added this to our backlog. We have Hussein, who asks whether we support OAuth 1, OAuth 2, or OpenID Connect. The answer to that is because API gateway doesn't own the identity of the end user, we cannot verify those tokens. So what we ask you to do is configure API gateway in such a way that the OAuth headers and tokens are forwarded to your backend where you can do the authorization. If you use AWS IAM and, for example, temporary cognito credentials, then we can do that authorization for you and verify the signature on the request. Sayed is asking, for the API to return context-specific responses, it will need the consumer's identity information, and the API key is in use for that. That is correct, and this is partly why I answered on the OAuth to the fact that we don't own the identity. So we cannot verify those tokens. We need to forward them to your backend where you can do the verification. However, if you do use AWS SigV4 and temporary credentials with Cognito, then we do have the notion of an identity ID, and that is the identity of the specific end user that's making the requests. And this identity is available in the context. The context is both the Lambda context as well as throughout AWS. For example, you could define your access policies to only allow access to an S3 folder to a specific identity ID. And if you use Cognito credentials, that is automatically available to you. Michael asks, how is the cache kept in sync with backend resources? When you create a cache and you deploy a cache for API Gateway, we use your API configuration to read for each method which parameters go and form the unique key of an item in the cache. And then for each stage, you can specify a time to live for that item. We will honor that time to live, and if it's expired, then we'll go and make the request to your backend again. And as we send the response out to the client, we will update our cache. Next is Eric, who asks whether you can make multiple backend requests for a single front-end request. API Gateway does not support orchestration out of the box, meaning you cannot configure orchestration in a visual way from the console. However, what we've seen many of our customers do is use AWS Lambda functions to do the orchestration and group the output of multiple calls. Next, we have Alan, who asks whether there is a way to keep the API code in a repository and deploy to API Gateway from there. We support Swagger import. So if you define the shape of your APIs using Swagger, we have an open source tool that is available on the AWS Labs GitHub account that can read your Swagger definition, import it into API Gateway, and deploy it. So you can make that part of your build process. Dushian asks whether API Gateway is available via CloudFormation. No, not yet. At the moment, we only worked on Swagger import because that's what most of our customers told us was important for them, because they worked with Swagger and that's how they defined and imported their APIs. However, we have received requests for CloudFormation support, so it is an item on our backlog. Jeremy is asking whether it can trigger Lambda functions directly. So the answer is yes. You can configure API Gateway to call straight to your Lambda function, execute it synchronously, and grab the output. We have Gerardo, who says, can the API Gateway be pointed to a public-facing ELB? Yes, it absolutely can, so long as there is a way for us to recognize that ELB. So it either needs to be a domain name that you've pointed to that ELB, or you need to give us the IP address directly. But yes, so long as the endpoint we are calling to is publicly accessible, we will make a call to it. Jordan is asking whether you would still get charged for API calls made during a DDoS attack. The answer is no, because API calls during a DDoS attack, API calls that are recognized at a DDoS attack, are blocked at the edge. And if we do let some of them through, then you can simply work with support and we'll make sure to get rid of those charges. Eric is asking whether API Gateway can use an IAM role for invoking a Lambda function. The answer is yes, and there's two ways to do it. Actually, there's three ways to do it if we want. First is if you're using AWS Auth for your client, so you're using temporary credentials in your client, you can tell API Gateway to use those temporary credentials to invoke the Lambda function. And because those temporary credentials are tied to a role in your AWS account, then the Lambda function will have the same permissions that that role has. Second, when you configure API Gateway by default without telling API Gateway to forward the caller credentials, we will use resource policies on Lambda, and we will simply grant API Gateway access to that Lambda function, and the execution role you've assigned to that Lambda function will regulate what the function has access to. And finally, you can set up the access to Lambda as the AWS Service Proxy rather than using the native Lambda integration. And in the AWS Service Proxy, you will be able to specify a specific role that we should use to invoke that Lambda function. Sean is asking whether API Gateway does any sort of load balancing. No, API Gateway will simply call an endpoint. If you host your backend on EC2, for example, then you should point it to an ELB to do load balancing for you. Where API Gateway helps you is with the throttling rules, where you can tell us that your backend can only handle 300 RPS, and we will not send more than that. Arun is asking whether it's easy to invoke a Lambda function through Cognito temporary credentials, and whether you're able to do the same from a browser. The answer to that is yes, it is simple to invoke a Lambda function using Cognito credentials. What you need to make sure of is that you give the role that your Cognito identity pool uses access to invoke Lambda functions. Michael is asking whether there is a SOAP version available. The answer is no, API Gateway does not natively support SOAP. However, you can use the transform templates to make your responses look like they were SOAP. Peter is asking whether the API will pass back all the headers for the response generated by the final API endpoint. API Gateway will pass all of the headers that you tell us we should pass. So as long as you declare the headers, and in your case I see you're asking about CORS, so long as you declare the header, for example, access control allow origin, we will pass it back. And you can either grab the value for the header from your backend response, or you can give it a static value in API Gateway. For example, you could simply tell us that the access control allow origin header as a value of star, and we will always return that value. Karen is asking whether we can throttle by API key and whether we have different tiers of throttling. At the moment, API Gateway can only throttle at API or method level. It cannot throttle by API key. However, this is another request we received from our customers, and it is on our backlog. Then Songwen is asking whether they can route API calls to different backend endpoints based on some property and input data. At the moment, no, you need to specify the endpoint in your API configuration. However, this is another request we've heard from our customers, and it is on our backlog, and we are looking at it. Olek is asking whether API Gateway utilize autoscaling group to tell which instances to communicate with, like ELB. No, API Gateway simply expects an HTTP endpoint. We don't look at the autoscaling groups or the VPCs within your account. And as we mentioned earlier, you can use the CloudWatch metrics that we collect for you to set up alarms and potentially work with your autoscaling groups. Jeffrey is asking whether the iOS SDK, Swift, or Objective-C At the moment, the iOS SDK is Objective-C. Songwen is asking, I developed an API in the US West Oregon region, and when I switch to US East, you don't see the API. That is because the API are configured and hosted within a specific region. However, we do create a CloudFront global distribution for the APIs, so as far as your end users are concerned, their connection will only go from their device to the closest POP available. And from that POP, it will be routed to the region where your API is configured over the Amazon network. Gareth is asking what happens to API calls that are throttled and whether they error or they're held. If an API call is throttled, we return instantly, and we return an HTTP status code 429, which is a standard for throttling. And if you do use our generated client SDK, then they will automatically know how to handle that response and retry the request. So we do not hold them and wait. Aaron is asking whether there is a method to simply invoke Lambda through HTTP request, passing simply the parameters without including any SDK or signature. The answer is yes. You could declare an endpoint in API gateway that is completely open, i.e. telling us not to verify the signature on the request. And from that endpoint, you could send straight through to Lambda, and then it will be up to your Lambda function to decide whether to authorize the call or not. Tress is asking whether it's possible to push messages to an SQS queue. The answer is yes. As we discussed, we offered this AWS Service Proxy integration type, where you can simply select the service you want to use and tell API Gateway what the request to that service looks like. And we will take care of signing the request and connecting directly to STS. Okay, we were waiting for more questions to come in. Now we have some more. Can the API, Scott is asking, can the API point to an auto-scaling group with an ELB in front of it? The answer is yes, so long as we have a domain name or an IP address to call that ELB with. Vish is asking whether the throttle period is a sliding window, number of requests in the last hour, or happens at the top of the period. This is a fairly complex subject. The way you specify how to throttle for API Gateway is requests per second. And to handle throttling, we use what's called a token bucket mechanism. So if you tell us that you can only accept a burst of 300 requests per second, then you will also tell us at which rate your bucket should be refilled. And without going into too much detail, the idea is that for each one of your API, we have this bucket with 300 requests allocated. As we receive requests, they consume the availability in the bucket, and the rate tells API Gateway how quickly that bucket should be refilled. But in terms of period is requests per second, and we measure it over a short number of seconds. Olek is asking whether he can export and access Swagger definitions for APIs that I defined in API Gateway. We don't do that natively at the moment. However, the tool we built to import Swagger definition is open source and available on the AWS Labs GitHub account. So we will keep improving on it, but you can simply take a look at that source code, and all it's doing, it's using the standard Swagger libraries to parse the Swagger file and then making the corresponding API calls to the API Gateway APIs to create that definition. So the same could be reversed very easily. Sanjeev is asking whether the Lambda integration is real time or you're taking some latency. Obviously, when API Gateway makes a call to Lambda, that is still an HTTP call. So small though as it may be, there will be a few millisecond delays. What you need to keep in mind is that your Lambda environment needs to be warm. If you haven't made any requests to the Lambda environment, then Lambda will need to start your machine and your container. So your first few requests may take longer than if you had the environment constantly being hit by requests. Michael is asking what language is used for the models in API generation. We use JSON Schema to declare models. Rohit is asking whether we can add business logic in API Gateway and whether we can hook up our code before the API call is made. Not at the moment. What we'd recommend you do if you want to add some business logic to API Gateway is use a Lambda function in between. So you could declare the endpoint on API Gateway to call the Lambda function and then have the Lambda function perform the business logic you need and make the request to your backend. Vern is asking how the API Gateway's cache is different from ElastiCache. The difference is that API Gateway's cache is completely managed. You don't need to call the ElastiCache APIs. We do that for you. All you need to tell API Gateway is how to build the unique key for an item in the cache, and it's time to live. And we take care of everything else. There is nothing for you to manage. Well, this is all we have time for now. Thank you very much for attending, and thank you for your questions and feedback. They were very helpful.